This is a simple problem. It says that a 9.4 kg projectile is fired vertically upward. So it goes vertically like that. And then air drag decreases the mechanical energy of the projectile earth system by 68 kilojoules. So the reduced mechanical energy is 68 kilojoule during the projectile ascent, when the projectile was going up. How much higher would the projectile have gone if air drag was negligible? So it goes like that. Let's say there is no air drag. In that case, it would have gone like that, let's say. Now, because of air drag, what has happened, it has gone only up to that point and come back. And it is saying that its mechanical energy of projectile earth system is reduced by 68 kilojoule. Mechanical energy means the sum of kinetic and potential energy. So the projectile starts with a kinetic energy, and as it got up to the maximum point, its it reaches maximum potential energy, kinetic energy becomes 0, and so on, but the sum is always constant. But because of air drag, when there is air drag, what happens is some of the potential energies is lost, because that is being used up by the air drag, the energy by air drag. So whatever kinetic energy it was with which it started its ascent, all of it didn't convert into potential energy. Some of it was used up by the air drag. So that is why it achieved only that much potential energy, not that much. This is without air drag, and this is with air drag, with the presence of air drag. So this is the kinetic energy, this is the energy that is lost. So the question is how much it would have gone up had there been no air drag. So that will be the potential energy lost is the energy lost due to air drag. So this much potential energy, and we know potential energy is associated with height. So mgh is potential energy. So this much height it would have gone more. This much high it would have gone more if there was no air drag. So that will be h here. So this one, if we equate mgh, the height that the more height that it would have achieved if there was no air drag, that h times g times f m will be equal to 68 kilojoule. So h becomes 68 into 10 to the power 3 divided by 9.4 is the mass, and 9.8 is g. So result is h is equal to 738.16, I guess I got, 16 meters. So that is the height, greater height it would have achieved, it would have ascended if there was no air drag. So we don't have, the only information that we have is how much the mechanical energy is lost because of air drag, and that mechanical energy would be used up. So if I say again, this is the kinetic energy toward in the beginning, so maybe initial kinetic energy, and as soon as the projectile is going up, what's happening is this kinetic energy is converted into potential energy, but at any instant, when there is no air drag, the kinetic energy plus potential energy, the total mechanical energy is constant. So when it reaches maximum height, what happens is its kinetic energy becomes 0, because velocity becomes 0, but all of that initial kinetic energy is converted into potential energy. So that would be mgh. So now what's happening, let's say that is mgh, I don't know, hf final, though it probably doesn't make much sense. That much height it would have gone if there is no air drag. But if there is an air drag, what happens is kinetic energy is still the same initial, but it achieves a lesser height, which is, I don't know, maybe ha, I don't know, I'm just giving random subtitles anyway. So mgh here, and ha is the height that is with air drag, maybe ad with air drag, and plus the energy lost due to AD, UAD, let's say. So this one will be the additional height that it would have achieved. So that would be mg hf minus HAD. So that would be the additional height, and that's what we needed to find in this problem. What's the additional height it would have achieved, it would have ascended if there was no air drag. So hopefully it makes sense. So yeah.